We are now in section 10.5, covering surface area of pyramids and cones. All right, so if we look at these two pictures first, you're either going to have a regular pyramid or a non-regular pyramid. So what does a regular pyramid mean? It means that the base is a regular polygon and all of the lateral faces are congruent isosceles triangles. That's important. A regular pyramid is a regular polygon and the lateral faces are congruent isosceles triangles. So, the vertex of a pyramid would be the point that is opposite the base. So these are the vertices. Now the slant height is the distance from the vertex up here to the midpoint of an edge of a base. Now that's the slant height of a regular pyramid. The altitude of a pyramid is the perpendicular segment from the vertex to the plane of the base. So if we look here, the altitude only on this one goes from the vertex, it's 90 degrees right here. Over here, it could be something that is perpendicular, a segment that is perpendicular from the vertex to the base. The lateral faces of a regular pyramid, so the faces all the way around, the lateral faces of a regular pyramid can be arranged to cover half of the rectangle with a height equal to the slant height of the pyramid. The width of the rectangle is equal to the base perimeter of the pyramid. That is really confusing. Let's do this again. The lateral faces, here they are, can be arranged to cover half of a rectangle with a height equal to the slant height of the pyramid. The width of the rectangle is equal to the base. So you'll see here the perimeter, side, 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 side. These represent the sides, or 4s. Remember, this is a regular pyramid. So since this is regular and it's four-sided base, this is a square. So that means, to get the perimeter, I would just take one of these sides and times it by 4. Now L, which is right here, is the slant height. And the slant height goes from the vertex down one of the faces, and it's perpendicular to the edge of the base of the bottom. So if we look here at our formula, the lateral and surface area of a regular pyramid, the lateral area of a regular pyramid with perimeter P and slant height L is this. You're going to take 1/2 of the perimeter multiplied by the slant height. So the perimeter multiplied by the slant height and then times 1/2. The surface area of a regular pyramid with lateral area L and base area B would be to find the lateral area plus the area of the base. The lateral area plus the area of the base. Or, if you plugged it in, the lateral area is 1/2 perimeter times slant height. So you would do 1/2 the perimeter of the base multiplied by the slant height plus the base area. This is how you find the surface area of a regular pyramid. Now, if it's not a regular pyramid, you would have to find the area of all of the sides and then add them all up. So in example 1, let's find the lateral area and surface area of the pyramid. So in A, we have a regular square pyramid with a base edge length of 5 inches and a slant height of 9 inches. So, lateral area first. The lateral area is just 1/2 multiplied by the perimeter of the base times the slant height. So that would be 1/2 times 20 times the slant height of 9, super easy. That's going to give us 90 squared inches. So that would be the lateral area. The surface area is the lateral area, which is 90 square inches, plus the area of the base, which is 5 times 5, which is 25 square inches. So the surface area would be 115 square inches. So part B. Part B, we want to find the lateral area. Now right here we have a hexagonal pyramid. So the lateral area is what? It's 1/2 the perimeter multiplied by the slant height. Well, the side length is 4. So that's going to be 4 times 6, which is 24, multiplied by 7. So that's going to give me 84 squared meters. That's easy. But now we have to find the surface area. And the surface area is the lateral area plus the base area. But the base area is, once again, 1/2 the apothem times the perimeter. Now, once again, it's not always going to be this easy with a hexagon. A hexagon, as you already know, actually, that's a pretty good hexagon, breaks this up into equilateral triangles. If we don't have that, you're going to have to use trig ratios to find the apothem. Now, in this case, we know the side length is 4, so this is 2. We know this is 30 degrees, so the apothem is going to be 2√3. Now, if you don't know that, then you don't know your rules for a 30, 60, 90 degree triangle. Remember, the long leg is the short leg multiplied by √3. So in this problem, we'd have surface area equals 84 plus 1/2 the apothem, which is 2√3, multiplied by the perimeter, which is 24. So we'd have 84 plus 24√3. Now, if you wanted the exact value, we'd leave it like that, and then you put a label at the end. But we can round to the nearest tenth, which would give us 125 6/10 centimeters squared. Now we're going to talk about cones. It's the same premise. We're either going to have a right cone, where the altitude is going to be the height from the vertex to the center of the circle, and it's perpendicular, or an oblique cone, which is not going to be that. So the vertex of a cone is the point opposite the circular base. The axis of a cone is the segment with endpoints at the vertex and the center of the base. The axis would be the altitude if it's a right cone. If it's not a right cone, then it's an oblique cone. Therefore, the axis is not perpendicular. Notice that the slant height is only on the right cone. So the slant height of a right cone is the distance from the vertex of a right cone to the point on the edge. The altitude of the cone, like we just said, is a perpendicular segment from the vertex of the cone to the plane of the base. Now, your formulas. Now, remember, you've done formulas for cones before, or you should have, but you've never done it with the slant height. And so that's why now we're incorporating the slant height. You may not always have the actual height of the cone or the altitude of the cone. So the lateral area of a right cone with radius r, remember this is a right cone, with radius r and slant height L, is pi r multiplied by the slant height. Right there. The surface area is this should make sense to you. The yellow is the lateral area, the blue is the base. The total surface area is the L plus the B. But in a circle, the lateral area is pi r slant height, plus the base, well, the base is just a circle. So your formula is pi r L, which is the slant height, multiplied by pi r squared. So let's do an example. All right, please ignore this little, whatever this is up here, this 1 of 1 thing. It somehow is appearing on my iPad. All right, example 2. Find the lateral area and surface area of the cone. So here we go. We have a right cone with radius 2, slant height 3 meters. Pretty easy. Start with the slant height. Pi r times the slant height. Well, that's easy. If we leave it our answer in terms of pi, r is 2, L is 3, it's 6 pi squared meters. The surface area is going to be 6 plus the area of the base. So that's going to be the radius, which is 2, be 4 pi. So 6 pi plus 4 pi, which would give us 10 pi squared meters. Pretty easy. So in example B, which is going to show up here in just a second, example B, we have a radius of 5 and an altitude of 12. The first thing I need to do, find pi RL. Here's the problem. I don't know the slant height. We do have a right triangle, so knowing that we have a Pythagorean triple, if you don't know, a Pythagorean triple would be, in this case, 5, 12, 13. If you didn't know that, we would do 5 squared plus 12 squared equals L squared. And you would eventually get L squared equals 169. And the slant height would be 13. So we take pi times 13 times 5. If we left this in terms of pi, you're going to get 65 pi as the lateral area. Now the surface area is the lateral area added to the area of the base. Well, that's easy. It's a circle. So we have 25 pi. And our answer would be 65 pi plus 25 pi, which would be 90 pi feet squared. Now in this example, exploring the effects of changing the dimensions. Once again, you just make an example and do it and figure out what the effect's going to be. But you can skip all this. All of a sudden, we see that the radius and the slant height are going to be tripled. If this is going to be multiplied by 3, and this is going to be multiplied by 3, your final answer, since we're talking about area, which is squared, it's going to be multiplied by 3 squared, which is 9. So we can skip right to the answer and know that the surface area is going to be multiplied by 3 squared, or 9. In example 4, we want to find the surface area of this composite shape. But here's our problem. The surface area in this case would not include the area of this circle right here because it's like smushed together. So we only want the lateral area of the cone and the surface area of the cylinder, but we want to subtract out one of the bases. So let's start with the lateral area of the cone. We know the lateral area of the cone is pi radius multiplied by slant height. Well, the radius is 28. We don't know the slant height, so you'd have to do Pythagorean theorem. So we know this piece right here, 90 minus 45, this gives us 45. So if you did 45 squared plus 28 squared, that gives us L squared, which is the slant height. I'll tell you, if you solve this, the slant height is going to be 53. So that means the lateral area only of the cone is 1484 pi squared centimeters. Now the cylinder, the lateral area, we want the lateral area of the cylinder, and the lateral area of the cylinder is what? Well, it's 2 pi RH. That's base times height of the rectangle. Now usually it's going to be 2 circles, but I only want 1 circle because I don't want the other circle. So I'm just going to add pi r squared. So if we plug this in, 2 pi times the radius times the height of just the cylinder plus pi radius squared. This entire thing is going to give us, 2520 pi plus 784 pi centimeters squared. We're going to add all 3 of these up, and we are going to get 4,788 pi squared centimeters. And that's our answer. Notice that it did not say to leave your answer in terms of pi or to round, so you can do either one. I honestly think it's easier. If it doesn't tell you what to do, just leave your answer in terms of pi. It's much easier. And our last example. Tim is replacing a paper cone. This is three-dimensional. This is not a circle. Of an antique speaker. He measured the existing cone and created the pattern for the lateral surface area from a larger circle. What is the diameter of the cone? So he cut it, and then he got this. So we know the slant height here would be 10. So what do we know? We know that the lateral area, which is pi r l, this is all this is the lateral area that he's unfolded. It's going to be equal to 3/4 of pi r squared. So here's what we're looking at. This piece right here of the speaker is the lateral area. So that's pi r l. If he unfolded it, he got 3/4 of a circle. Well, 3/4 of a circle is 3/4 pi r squared. We want to know what the diameter is, so we have to find out what the radius is. So pi times the radius, which we don't know, of the cone, and the slant height. Remember, this is the radius of the cone, this is the radius of the circle. I don't know the radius of the cone, but I do know the radius of the circle. So 3/4 pi, the radius of the circle is 10 squared. So this is going to give me pi r, oh, I forgot to put the slant height in. The slant height's 10. 3/4 pi multiplied by 100. I'm just going to divide by 10 pi. Divide by 10 pi. That gives me the radius is, if you multiplied all this, the pi's cancel, you're going to get 7.5 inches as the radius. So the diameter would be 15 inches. Your vocabulary would be slant height of a regular pyramid, axis of a cone, oblique cone, slant height of a right cone. Now we've done other things, but these are the ones that are new, and I want you to make sure you know them.